Hello everybody, Mr. Barry back here with one last video for the week in adding, subtracting, multiplying polynomials. I'm going to be focusing on multiplying polynomials and some of the more difficult problems that we're going to see within those situations where we have to multiply polynomials. So here we're going to start off and say that we can see we have a binomial times a binomial here, and my main focus is on this spot right here because I have the two parentheses, and in previous videos you've seen maybe a plus sign between those two parentheses, maybe a minus sign between those two parentheses, and we've added or subtracted eventually. But here there's nothing right there. The two quantities, in this case it's a binomial times a binomial, there's nothing separating them. So we can understand that as multiplying polynomials here. And we have done examples where you've had a monomial times a binomial and we just distributed here. We're going to do something similar to that. And I'm going to try to color coordinate this as best as possible here. I'm going to take a look at the term 7x over here first, and I'm going to, because we're multiplying the polynomials, I'm going to go ahead and distribute that to both of the terms in the second parentheses. So 7x, I'm going to multiply times 4x. Seven times 4 is 28, and x times x would be x to the first power for both of those, so it would be x squared. I'm then going to take the 7x and I'm going to distribute that also to the second term in that parenthesis, which is negative 4. So 7x times negative 4. And remember here, we don't need like terms to multiply. We can multiply anything that we want at all in math here. I have 7x times negative 4, that would give me negative 28x. I've distributed everything in this 7x, everything I could distribute to that over here in the second set of parentheses. I've already done that. So I'm going to kind of just scratch it out here just to remind myself that I've used up the 7x as much as possible. I've distributed all I could. And I've got to do the same exact process to the 7, the second term there in that set of parentheses. So let's go ahead here and we'll take this 7 and we're going to distribute to that 4x. And that would give us here a 28x. And then finally 7 times the negative 4. And that would give me negative 28. So just point this out to you here. There's an acronym that you might have heard about in math first that we kind of just did. And I'm going to color coordinate that also. If you take a look here, this term 7x that we used over here times that 4x, those are the first two terms in both parentheses. And if you take a look at the 7x that we use times the negative 4, those are the two terms that are on the outside of the whole picture. Then we moved on to the second term in the first binomial, and we did 7 times 4x, and those two terms would be the inside terms of the whole picture. And then finally, we have the 7 times the negative 4. Those two terms would be the last terms in both sets of parentheses. So some teachers like using this acronym, some teachers don't like using this acronym, but if you ever hear anybody reference the word or the acronym FOIL, this is what we're talking about here. Where you distribute a bunch of different things here. We're multiplying polynomials, and it's a binomial times a binomial. That's really where we use the acronym FOIL if it's a binomial times a binomial. There is more things to do here, but if you hear FOIL, that's that process that we're kind of using there where we distribute to the binomials. Let me rewrite down some of these terms that we have here, we have a 28x squared, we had a negative 28x, we had a positive 28x, and then finally we had a negative 28. A lot of 28s in this problem. We still need to go through the process here. We've gotten rid of all of the parentheses involved, so now there is no longer any distribution. I do want to combine like terms where possible, and I would like to put this in descending order if possible. So the first and the term with the largest exponent would be 28x squared. There's no other term with an x squared involved here. Kind of gets a little bit weird here as we go negative 28x plus 28x. And if I combine those like terms, negative 28x plus 28x would actually make 0x. And then finally, there's the constant. We have negative 28 kind of all by itself. There's no other constant involved here. You might be ahead of me and say, well, we don't really write down things that involve 0x. 0 times x would just be 0, which is fine. I just kind of wanted to show what was going on there. So if I had to write this out as a final expression with all of my terms combined, as much as they possibly could be, I would have 28x squared minus 28. In my next example here, again, you can kind of see that I'm dealing with a binomial times a binomial. So I'm going to take the items, the terms in the first parenthesis, and I'm going to distribute them to the terms in the second parenthesis. I know that I'm doing multiplication because, again, I look in between these two parentheses. There's not a plus sign. There's not a minus sign. The parentheses are just right next to each other. Therefore, I know that multiplication is happening. So I'm going to start off with the 8n squared. I have 8n squared times 6n squared. If you like the concept of FOIL, remember that that would be the first two terms in both sets of parentheses. Remember, that's 2 plus 2 for the exponents there, not 2 times 2. 2 plus 2. So that is our first. Go ahead and now do 8n squared and distribute that to the negative 7n. And gotta go ahead and erase that. So we have 8 times negative 7 is negative 56. And then I have n squared times n. So that would be exponent 2. Plus exponent 1 for a total of an exponent of 3. And again, if you like our FOIL concept here, that would be the two outside terms in this total picture. I've used up all of the things that could be distributed for the 8n squared. So now I move on to my negative 1. And negative 1 times 6n squared would be negative 6n squared. Those are my two terms that are on the inside of the total picture. And finally, we'll go ahead and do negative 1 times negative 7n. And negative times a negative would give us a positive 7n. Those two terms would be the last two terms in each of our parentheses. So again, some people like this, some people don't. There's our FOIL for this problem. I'm going to rewrite out each of the terms that we have here. I'm going to do that to kind of show here that we no longer have any multiplication going on in the problem. I got 48n to the fourth power minus 56n to the third power minus 6n squared plus 7n. And if you can notice there, when we try to combine like terms here, there's no like terms there. They all have a variable n, but they all have different exponents for that variable n. So There's no simplifying to go on here. That right there is our final answer. 48 n to the fourth power minus 56 n to the third power minus 6n squared plus 7n. One last problem here, and I have 2x minus 1, which is a binomial, and I'm going to multiply it to 4x squared minus 3x plus 2, which is a trinomial. And I know I'm going to multiply here because, again, there's no symbol in between the two parentheses. They're just kind of smushed together there without anything plus or minus sign in between them. And you might say to yourself here, we're going to go ahead and do the same exact process. And I want to go ahead and multiply and distribute out terms from the first term, terms from the first quantity to terms in the second quantity. You're doing the FOIL method. However, there's more than just a first, an outside, and a last. So I think this is one of the reasons why people try to stay away from the FOIL method. So we just know that we're going to go ahead and do a lot of distribution here. But that process still holds true. So I'm going to go ahead and I'm going to distribute 2x to every single term in the second quantity there. So I'm going to do 2x times 4x squared. I'm going to do 2x times negative 3x. And I'm going to do 2x times 2. And remember, again, it's not necessarily an absolute must that we have like terms here. So I can multiply all these items out here. I distributed the 2x to every single term in that second parenthesis. So I'm going to just scratch it out to remind myself that I'm done with using that 2x. Go ahead and distribute the negative 1 to every single term in that second quantity. And I get negative 4x squared, positive 3x, and a negative 2. We want to make sure to try to group like terms here. I'm going to write this out just once. I do want to kind of show you a little bit of a trick here. So in green, we had 8x to the third power minus 6x squared and plus 4x. And maybe somebody that like this, maybe you like using the symbols like I did previously, but this is one of the things I like to try is that when I look over here at our purple terms that I did second, if I could stack the like terms, it kind of cuts out some work afterwards for me. So I know that that negative 4x squared is going to be like terms with the negative 6x squared because of the 2 exponent. I know the positive 3x would be the same, like it would be a like term with 4x. And then we have a negative 2, and there's no constants in green. So I'm going to go ahead and put a negative 2 on the back end here. That kind of helps me see the like terms a little bit better. It's just one of the things I like to do. And we can go ahead and combine like terms. Negative 6x squared minus 4x squared, those are like terms. Negative 6 minus 4 would be negative 10x squared. 4x plus 3x, that's going to be positive 7x. And then I have finally a minus 2. No more like terms at all. And if we're doing this problem, that right there would be as simplified as we can go. 8x to the third power minus 10x squared plus 7x minus 2.